Good day, sir. We are the group a philosopher, not scientist, Char. And we are here to discuss what we have researched according to the first task that you have given to us. So our first person that will discuss his research is Jerry Galbo.
Okay, good morning, everyone. Good morning, sir. Please do allow me. I am Jarek Figalbo, and please do allow me to share my answers on the two given questions. How does objects are charged and quantization and conservation of electric? How do objects are charged? An electrical charge is created when two materials come into contact or are rubbed together. It is created when electrons transferred to or removed from an object. When electrons are added to an object, the object becomes negatively charged, since electrons have a negative charge. On the other hand, if electrons are removed from an object, the object becomes positively charged. When the materials are in contact, electrons can be literally rubbed off of one object onto the other. But this doesn't necessarily mean that any of the two materials rubbed together will literally cause electrons to move. Some of them are much more willing to donate electrons, and others are more likely to accept electrons. This explains that the objects are diverse and has different characteristics, especially when they are rubbed together. To dig deep, most objects are electrically neutral, which means that they have an equal number of positive and negative charges. Charge balance of positive and negative charges has to be altered in order for an object to be charged. There are three ways on how to charge an electrically neutral object. First, charging by friction. Second, charging by conduction. And third, charging by induction. Furthermore, to charge a material, you can remove some of the electrons or add some of electrons as you cannot lose electrons. Making one thing necessarily positively charged makes another negatively charged, depending on the method someone is using. Congruently, to make something neutral again, you restore balance between protons and electrons, which otherwise known as the discharging. Okay, moving on to the number two question, quantization and conservation of electric charge. Electric charge is the basic property of matter that causes it to experience a force when kept in an electric or magnetic field. An electric field is associated with an electric field, and a moving electric charge generates a magnetic field. Conservation of electric charge is the principle that the total electric charge in an isolated system never changes. The net quantity, the amount of positive charge minus the amount of negative charge in the universe, is always conserved in the context of electric charge. The law of conservation of charge says that the net charge of an isolated system will always remain constant. There is possibility of two ideal states for a system for multiple objects. First, all the object has a net neutral charge. In the whole system, there's the same number of protons and electrons. For each proton, there should be an electron in order to balance it. Second, the net charge of the system being distributed uniformly in the objects. Rather than concentrating negative charge in a few bodies, the charge on the body is evenly distributed throughout by the transfer of the electrons, in which can be achieved through the transferring of electrons from higher polarity to lower polarity. In this situation, only electrons are involved, not protons. That would be all. Thank you.
Thank you, Jeric. So, next will be Ruth Jean.
Good morning to everyone, especially to you, sir. Have a nice day. So these are the information that I gathered from the internet. So the question number one: how does an object get a charge? Does gain or lose question. What does it mean when an object is positively charged and how about negatively charged? So an object gets a charge when it's rubbed. This rubbing causes the object to gain or lose electrons. When it loses electrons, it becomes positively charged. Then when an object gains electrons, it becomes negatively charged. So as a result, most items have a neutral electrical charge. An object can be charged in three different ways. We have friction, conduction, and induction. So, if the electrons move from one surface to another, it is the result of friction, which is the rubbing of one material against another. So, when the materials that are poor conductors, such as insulators, can be charged with friction. So, on the other side, conductivity is used to charge materials like metals, which are good conductors. So a portion of the charge, whether positive or negative, it will transfer when a charged object is touched by a conductive material. So that is the conduction. So the induction, it is the last method of the charging for an object and is one more ideal for conductive materials. So the charged object is held close to the uncharged conductive substance, which is grounded on any neutrally charged material. So the two items will exchange charges, and the uncharged conductor will produce a charge that is opposed to that of the first charged object. So, additionally, it is important to consider how electrical charge is quantized and conserved. Although electrical charge cannot be created nor destroyed, it can be transferred from one body to another. So we also have quantization of charge. Quantization of charge is the idea that all observable charges are always some form of integral multiple elementary charge, which is denoted by the expression E is equal to 1.6 times 10 minus 19 C, or Coulomb. So the transfer of an integral number of electrons when two bodies rub against each other, which results in the quantization of electric charge. Instead of existing continuously, charge only exists in the form of packets. So packets means like container, like that. The charge is hence said to be quantized. Furthermore, the concept of conservation of charge states that the total electric charge is in an isolated system always remain unconstant for all time. And that would be all. Thank you.
Thank you, Ruth. So, clear kayo mag-share, no? So, next will be,
Me.
yes, yes, sige, sige.
Okay na.
Go, Arnaline.
So good afternoon, sir. By the way, I am Arnalyn Dimindugungkay. So based on what I have research about the task one, which is the how materials are charged. So before anything else, to understand about what is electricity, we should need first to understand what is an atom. So inside an atom, atoms are particles of matter, and it once believed to be solid spheres, and now known to be made of three smaller particles: the protons, neutrons, and electrons. Protons are positive, while neutrons are neutral or no charge, and electrons are negative. So how materials are charged? So for example, when rubbing two objects together can cause the electrons in the atoms of one object to move into the atoms on the other object. Now, the objects are both charged. The object that lost electrons is positively charged, while the object that gained electrons is negatively charged. So in the law of charges, the unlike charges attract while the opposite charges repel. And the quantization of charge, the formula there is Q is equal to N of E, while the Q stands for the total charge of a body, while the N it is an integral multiple number, and the E is the basic unit. So let's proceed with the conservation of charge. So in the law of conservation of charge, it says that we cannot destroy or create a new charge. The number of charges in the nature are constant, which is the net charge is zero. We can only transfer it. So in the law is we cannot create and destroy a charge. And now, what do we do? So for example, we can only transfer charge from one body to another body. So for example, if I'm going to rub this pen to my clothes, this clothes transferred charge to this pen so that there will be some charges less and some charges addition, but the total will remain the same, and that's what we call the conservation of charge. That's all.
Thank you, Arnalyn. Napadjud siya pa sampol-sampol. So, next is Mika.
Good afternoon, everyone. Good afternoon, Sir Reg. By the way, my name is Micaela Bidinoy, and now I will be sharing my ideas based on my research in the first task or the task one, the synthesis. So the first question is how the object are charged. So before that, I will define the electrical charge. So what is an electrical charge? An electrical charge is created when two materials come into contact or are rubbed together. When the materials are in contact, electrons can be literally rubbed off of one object and onto the other. This doesn't mean that any two materials rubbed together will cause electrons to move. Some materials are much more willing to donate electrons, and others are much more likely to accept electrons. So, a list of materials ordered by their ability to donate electrons is called a triboelectric series. So, what is triboelectric series? So, the triboelectric series shows the static electric potential of common materials. Materials towards the positive and give up electrons when brought into contact with materials towards the negative end. So most of us have probably all generated a static electrical charge at some point in time. For example, when you walk across a carpet and touch a metal surface, or when you feel the cling of statically charged clothing, are those evidence of static electrical charge. So, how objects are charged? So, an object are charged, or an object gets a charge when it is rubbed. This rubbing causes the objects to gain or lose electrons. When it loses electrons, it becomes positively charged. When an object gains electrons, it becomes negatively charged. So that's all about the first question. So the second question is the quantization and conservation of electrical charge or electric charge. So, as what I've said earlier, electric charge is the transfer of electrons from one material to another. So, negative charge means that there is an excess of electrons, while positive charge is a deficiency of electrons. When we refer to something as having a certain charge, we actually mean how many times the charge of a single electron it has due to the quantization of charge. This is possible because each charge has an associated whole electrons. Quantization of charge means that when we say something has a given charge, we mean that is how many times the charge of a single electron it has. It implies that charge can assume only certain discrete values. Remember, there is no scientific explanation for the quantization of electric charge in electrodynamics theory and modern physics, but it can be verified experimentally. This approach uses the allowed invariances of the Lagrangian and their associated anomaly cancellation equations. So, because the fundamental positive and negative units of charge are carried on protons and electrons, we would expect that the total charge cannot change in any system that we define. In other words, although we might be able to move charge around, we cannot create or destroy it. This should be true, provided that we do not create or destroy protons or electrons in our system. In the 20th century, however, scientists learned how to create and destroy electrons and protons, but they found that charge still conserved. Many experiments and solid theoretical arguments have elevated this idea to the status of a law. So, the law of conservation of charge. It says that electrical charge cannot be created or destroyed. So, that would be all, and thank you.
Wait. So, good afternoon, sir. Good afternoon, everyone. Still it. I wonder why does my hair stand up when I rub it on a balloon? So, when we were kids, who among you here do felt like it's kind of magical when we kind of rub the balloon into our hair, then our hair stands up? Who among you here had the experience? I think I am the only one experienced. But when I was a kid, I truly felt magical every time I rub a balloon into my head, and then if I'm going to like get it, my hair stands up. Now, when I grow up during my college year, I finally realized the explanation behind that. And thanks to this physics topic that we are having. So, according to Bobrovsky 2022, having your hair stand up is caused by the electrons that moved from the hair to the balloon. And this is because when electrons are negatively charged, balloons acquire a net negative charge also, which you already guys discussed earlier. So I'm not going to discuss it further because you already said it in here earlier. But how does negative charge object transfers its energy to the other object? So for further info, what does it truly mean also to have this kind of like electric charge? As we dig a little deeper into this topic, let's first meet atom, like what Arnelin um, talked about earlier. So atom is truly unbelievable if we're going to just think about it as the most important matter, even though with the fact that it is the smallest unit of matter according to International Atomic Energy Agency 2015. So how could one ever imagine that this tiny micro thing makes up everything around one's life without feeling great amusement? Because atom is the smallest thing in this universe, yet we could say that it is the most important among every matter because every matter is composed of atom, kind of like that. So in physics, atom is explained as most important building block of chemical structure. To form molecules, they have to bond together. Moreover, this matter is composed of three particles. So first, the proton, second, the electron, and then the third one is the neutron. So these three lead us to the fundamental laws of magnetism, which says magnets force exerted when they repel or attract each other, which is caused by the different electric charges. The idea is simple. Opposite charges attract and some charges repel. When two same charges are put together, protons or electrons to electrons, for example, they will repel from each other. But if two different charges are put closely together, they repel. But why? I think you've already explained it earlier, but I think it's justifiable if I'm going to say it again. Based on Vaidyanathan 2022, this is because the nature of electric force is just like that. Like charges repel because they push each other away, and opposite charges attract because they pull one another towards each other. But how will we know that an object will be positively or negatively charged? We will use the triboelectric electrostatic series. So it looks like this. Um, and look. So it looks like that. So as you can see, it's not clear, but it looks like that. And then it says there that there are some materials that belongs to the weaker giver of electrons, and some things belong to the greater receiver of electrons. And I think that explains why the balloon and the hair do have this kind of like electric charge, even though they are both matter that we can just hold into our hand. And then going back to a balloon, like what I've said earlier, if we rub it in our head, it will stick in our head. If we will pull it rather, our hair will stand up. And if we put it near the wall, it will stick in the wall. Kinda like magic, but it's not. Because again, it's just the law of charges. Like charges repel, and I like charges attract. The net positively charged human hair and net negatively charged rubber balloon are pulled towards one another. This charging process is commonly known as static electricity, which is simply defined as the result of negative and positive charges imbalance in objects. This occurs when a thing obtains a net amount of negative or positive electric charge. But there are three types of charging process in static electricity, and these are friction, conduction, and induction. And I think it was Ruth Jane who already talked about it earlier. So charge of friction occurs when two objects are rubbed together, just like the balloon and the hair. So if I'm going to rub a balloon into my hair, then but before that, before rubbing each other, the two different matter have initial neutron charges. And if I'm going to rub it, then this electric charge will then take place. Because after after I'm going to rub the balloon again and again to my hair, the electrons in my hair transfers to the balloon, making the hair positively charged. And the balloon, as a greater receiver of electrons, according to the electrostatic series, will then become negatively charged. Then, charged by conduction, on the other hand, is a process where a body gets charged when making contact with a charged object. Silver, gold, steel, seawater, and copper are great conductors. Charged by induction, on the other hand, is the process in which a body gets charged by a charged object without having any close contact. So correspondingly, law of conservation of charges must also be remembered when we will talk about especially static electricity, as it states that charges can't be destroyed nor created, but can be transferred from one object to another, like one of us said earlier. The total charge in a system must remain constant. In light to this, when one body is rubbed with the other, the integral number of electrons are transferred, leading to phenomena called the quantization of electric charge. So, in conclusion, physics is very magical, and it really do helps us to spark our curiosity. Because just imagine when you're just a kid seeing your hair standing up just because you rub a balloon. It's kind of like magic, diba? But when you already studied physics, kind of like this most simple law when it comes to studying electricity. So we realized that the question, why does my hair stand up when I rub it, or I rub a balloon on it is just an opener to a greater topic in relation with static electricity, and even to the smallest yet most fundamental matter of all, which is atom. Bagay na. Sige. So again, sir, good day, and that would be all. I'm Angel Grace F. Beato, and together with my Richard and Arnalyn, together we're Arnalyn, Jeric, and Micaela. So we are the group Philosophers, Not Scientists. Yes, and that would be all, sir. Thank you very much. We do hope that you have a great day, and anda sir lamay mo sudan. Char. So bye-bye, sir.